Okay, hello everybody, welcome. We're going to be talking about building applications with infrastructure as code today. My name is Talia, or if you speak Spanish, Talia, como la cantante. That's like the only Spanish I know, so don't ask me anything else. That's all I know. I am a senior developer advocate for a cloud company called Akamai. And before that, I was a developer advocate on a small cloud computing company called AWS. And I was on the serverless team there. Before becoming a dev advocate, I did automation, QA, testing, all sorts of end-to-end testing, CI/CD testing. And now I focus primarily on building in the cloud, building applications in the cloud. And right now I have a really specific focus of building with infrastructure as code, so using tools like SAM and Linode and Terraform. And so we're going to be talking about that a little bit today. So first we're going to go through an intro to infrastructure as code. We're going to talk about some of the use cases, what it means, like really define the parameters of infrastructure as code. And then we're going to talk about some of the different tools we can use, and we're going to compare them all at the end. So Linode, Terraform, AWS, Google, all of those tools. And then at the end, we're going to do a quick demo. Okay, so many times when developers start building applications, the first place that you go to build is the console, right? So you go to your GCP console or your AWS console, and you choose the services that you want, and then you connect them, right? So you're like, I want this Lambda function here. I want this as a trigger to my Lambda function. I want to have this database connected to this server, and you just choose everything from the console, right? So that's a really great way to learn how to use the cloud. If you've never used the cloud before, going into your cloud console and seeing everything in this UI, in this like graphic interface, is a great place to learn, because you can see, okay, this database is connected to this server, this is the trigger for this Lambda function. You can see everything in one place. The only problem comes when you want to move your resources from one place to another. Let's say you have a test environment and you want to recreate your production environment. Or let's say you want to test something, or there's a new developer, there's a new dev account that has to recreate everything that's in production to be able to build a new feature or something. Like, how do you reproduce what's in production right now? Like, how do you move resources from one account to another? Or the big idea is, how do you replicate the current application that you've created in the console? So chances are you're not going to remember exactly which resources, exactly which configurations you set in the first place. And so this leads us to something called infrastructure as code. And so this is basically how we solve this problem. We're going to look outside of the console to infrastructure as code. And so with infrastructure as code, you're automating the provisioning process. So instead of going to the console and choosing what services you want, so you want this Lambda function and this database and this server, you're not going to do it from there. You're going to configure everything with what's called a configuration file. And you're going to hear me say configuration file 100 times today. And that's really what infrastructure as code is. So you create this configuration file, and that's a definition of all of the resources that are in your application. So this is how you instantiate your infrastructure. You use this configuration file. You say, I want this Lambda function, I want this IAM role, I want all of these resources, and it's all in one place. So this configuration file is your one source of truth. It's one place with all the steps and all the configuration for your application. And so this allows you to use, to treat your infrastructure as code. And so what do you do with code? You version it, you check it into a repository, if something goes wrong, you can roll it back. So when you move to infrastructure as code, you can do the same thing to your infrastructure as you do with your code. So if something breaks and your infrastructure isn't working, well, you can roll it back, you can move it to a different environment, you can, make a change to it, or move it somewhere else. So it gives you like this one source of truth. And you also have the flexibility to build, change, and manage your infrastructure in a really consistent and repeatable way. And you have, when you're using like version control, for example, like GitHub, and you check in your configuration file, you have a history of everything that's going on inside of your application. And so you do have that to go off of. Okay, so why is this important? Like, why is building with infrastructure as code better than building within the UI, for example? So by using these configuration files, you're ensuring consistency across your environments. Like, this would happen all the time when I was a test engineer. I would get people come to me saying, oh, like this works on my machine. Like I would open a bug and say like, okay, this is the problem, and I would, list out all the steps to recreate the issue, and then I would turn it to the developers, and they would be like, well, it works for me, like it works on my machine. So this is one of the things that helps reduce those errors, because you do have this consistency across all of these environments. This is also great when you're onboarding a new developer. So let's say you're a new developer and you're joining this company and they use Google or AWS or Azure, and it's day one at the company, and you have to set up your environment because you're a developer, you're a DevOps engineer. So you go in and you sit down at your desk, and one of the lead engineers comes to you, and he's like, okay, this is how you set up your environment, and he gives you like a 300-page book, like, okay, good luck, and he like walks away. And then you go in the corner and you start crying because you're like, I don't know what this means, I don't know what any of this is, versus you give them a configuration file and you say, hey, deploy this, that's your environment, done, these are all the resources, just deploy it and you're done. Like everybody's happy. It's like one thing that you have to do versus, a 300-page book of like, do this, connect this. It's much easier when you're onboarding developers. Another benefit to using infrastructure as code. Oh my God, am I up there? Okay. Another benefit to using infrastructure as code is that it eliminates configuration drift. So configuration drift is there's a problem that happens during incident management. So let's say you get paged one night because there's an incident for your mobile application. And let's say you go in and you fix the issue because this issue it's a production issue, something's breaking in production, you have to go fix it. So you log into your system, you figure out what the issue is, and you fix the issue. And in order to fix that issue, you have to make a configuration change in production. So you go in, you make the configuration change, and then you go back to sleep because it's the middle of the night. And so that's great because you fixed the issue, but even though you fixed the incident, you've just created an even bigger divide between your staging and your production environments because you didn't make the same change in staging. So a lot of times, staging and production environments are very, very different because of changes made during incident management, and this is called configuration drift. So it also decreases risk. So provisioning all of your infrastructure by hand is very risky, right? Like it requires work that is manual, it's very error prone, and it also requires a single person to do. Like somebody has to go in and make those configuration changes. And what if that person leaves the company? Do they take all of that knowledge with them? So infrastructure as code minimizes those risks, and so you do have these reproducible blocks of code, and you use things like GitHub for version control where you can check all of your infrastructure and use it as code, and so its history and its changes are visible to everyone. So basically with infrastructure as code, rather than having this rather than having configuration drift, having this shift in environments, you have, like I said, one source of truth, one central authority, and that is this configuration file. Okay, so how do we actually implement infrastructure as code? So there's a few tools that we're going to talk about today. One of them is called Terraform. Terraform is an infrastructure as code tool that's used for defining cloud resources and on-prem resources. And Linode is a cloud computing provider. Full disclosure, I work for Akamai, and Akamai owns Linode, so I'm going to be doing a demo with Linode. But the point of this talk is I'm not trying to sell you Akamai, Linode, AWS, GCP, or Azure. I would like to teach you all how to use infrastructure as code. I'm here to teach you guys about this process that's really beneficial. So I don't care which tool you use. I don't care if you use SAM. I don't care if you use CloudFormation. I don't care if you use Terraform. I just would like you guys to try infrastructure as code. So I'm going to do a demo with Linode and Terraform, but use whatever tool you think is best for you. So let's talk a little bit about configuration files. Configuration files are declarative, and what that means is that you're describing the end state of your infrastructure. So you don't need to write step-by-step instructions to create resources. Like, you don't have to say, okay, open the console, and then click on Lambda, and then click on this, and then click on this, and then set the trigger. Like, you don't have to do any of that. You have to define your resources, and you're defining your end state. So you don't have to, describe any steps how to do it. You just define what you want. And so when you deploy this configuration file, your resources are either created, updated, or destroyed. So, if it's a new resource and it doesn't exist, it's going to be created. If you're updating something, it's going to be updated. And if you remove something from the configuration file, then it's going to be deleted. So in this example configuration file, we're saying, hello, please create this IAM role, and please create this Lambda function. And these are all of the configurations for this Lambda function, and these are all the configurations for this IAM role. So I don't have to say how to create these resources. I don't have to say, any steps. I just say, create this for me, thank you, bye. That's it. And so when we're talking about infrastructure as code, there's a few ways to go about it. And one of the ways to do this is with a core workflow, a core infrastructure as code workflow, and there's a few different commands that I want to talk about today. So the first thing we need to do is write the configuration file. This is where we define all of the resources like we just saw, and we do that with, if you're using Terraform specifically, use a command called Terraform refresh, and so this refreshes your application, and it finds the current state. So Terraform will go out and say, what's the current state of your application? It'll either say you don't have anything currently in production, so whatever you create is going to be brand new, or it'll say, you have these existing applications, or you have these existing resources. So it depends. Like, it'll check what your current state of the application is and what's currently running. And then what happens is Terraform creates what's called an execution plan. And so in this stage, you have to Terraform figures out what to do to get from your desired state, which is your configuration file, right? In your configuration file, you're defining, I want this resource, I want these configurations, this is what I want. That's your desired end state. And so then when you run Terraform plan, this creates an execution plan of how do I get there? What do I need to do to make this the reality and not a desired state? And then the last command that you run is Terraform apply. So this is where Terraform actually goes in and performs those commands for you. So this is when it'll go in and create the resources, it'll go and update the resources or delete the resources. Okay, so there's a couple of parts to Terraform that allow it to work. So first there is core. And core takes in that configuration file. It takes in that desired state. Again, this is the source of truth for your environment. And this is what it this is the state file that determines what changes need to be made. It keeps track of, metadata, and you can use this to like improve performance. There's like different configurations that you can do. And then on the back side, you have what's called providers. And so providers are things like infrastructure as a service providers like AWS, Google, and Linode, and Azure. You have platforms as a service like Heroku and Kubernetes, and then you have software as a service tools like Splunk and GitHub. And so these are all providers that you can use in your configuration files. They could be on-prem, they could be cloud resources, they could be all sorts of things. There's registries online that you can go to and find like lists of what is already out there. And so there's all of these important pieces that are connected in your application, right? You have AWS and GitHub and all these pieces that are important for the delivery of your application. They're all part of your logical end-to-end delivery. And so what's great about Terraform in particular is that you can manage all of these things in one place. So you have this logical end-to-end delivery of all of the parts of your application in one place. So you don't have to use one tool for your cloud provider and one tool for monitoring and then one tool for X, Y, and Z and all the other things that you have. You can do everything all in one place. One of the benefits that I'll talk about with Terraform that's different from the other cloud providers is that you have the ability to do multi-cloud. So with Terraform, you can use AWS and Google and Azure at the same time, like within the same infrastructure. And so you don't have to piece together what's AWS doing, what's Google doing. You can have all of these in one place. Okay, so I want to talk about adopting infrastructure as code because a lot of times, like, you didn't necessarily start building your application with these configuration files, and you might already have resources that are in production that weren't built with infrastructure as code files with these configuration files. So what do you do if you already have infrastructure? So on day one, this is like brand new, you don't have anything out there, you go from running nothing to running something. And so this is where you provision your initial set of infrastructure. So you describe what your desired configuration is, you write your configuration file. This is where you describe your desired state. And then there's the more challenging day 2+, and this is where you have your existing infrastructure and you evolve it. So you go from, maybe you want to change the configurations for your Lambda function because something changed, or maybe you want to go from running servers to running serverless, or maybe you want to change the capacity for a database. Like, this is where you're consistently evolving your application. But the great thing about having these infrastructure as code processes in place is that your day one looks just like day two. So you're still updating your configuration file. There's no new processes that have to be put in place. And then on day N, this may be in the future, this is where you can decommission your infrastructure. So let's say you created resources for a test environment and you don't need those resources anymore. You can just remove them. And there's a few different commands that you can run with, like SAM and Terraform, that will remove all of those resources for you. And if you're using Terraform, it'll specifically go to the providers and remove those specific providers. So I just want to stress the importance of the infrastructure as code process. Like, your configuration files are consistently evolving. They're consistently changing. Like, think of your application when you first started at your company versus what it is now. Like, it's consistently evolving. You're consistently making changes to it. Like, you might have a Lambda function one day, and that you might add a database another day. You might update configurations one day. There's different things that could happen in your application, and your infrastructure can either expand in complexity, it can decrease in complexity, and so over time, you'll likely add different pieces, more complexity, less complexity. And with infrastructure as code, you have, again, this one source of truth that's going to keep track of everything for you, and you don't have to make any specific process changes for those. There are many advantages to this workflow. What's great about Terraform is your day one experience is identical to day two, so you don't do anything different after you create your initial set of infrastructure. You can also destroy infrastructure, for example, like I said, for a test environment, you can remove those resources along with all of the data that comes with it. Your infrastructure is always going to be evolving, but again, your processes do not. And in this cycle, you go from running nothing to running something. You're constantly evolving it, and you have these processes in place to make that easier for you. Okay, so as your team grows, it can be challenging to manage your configuration files and to manage your infrastructure, right? So normally what happens at companies, especially with startups, is that you have one person who's like the DevOps guy, and he manages like all of your infrastructure. You know, he's the only person who knows about what's in your infrastructure, what's in your configuration file. Normally it's like, at a startup, it's like that one guy. You all know who I'm talking about. And what they do is they create that configuration file locally. And then, you know, they define all the resources in this configuration file. And then they create, you know, for example, with Terraform refresh, Terraform plan, Terraform apply. And that cycle continues with this one person, and that one person continues to evolve that infrastructure. But now, what happens when you go from a single person to, let's say your company grows, it's not necessarily a startup anymore, and you go from one person to a whole team. So in this case, like, other people are going to want to collaborate and manage some of the infrastructure, and you want to make sure that you have a consistent view of what's happening in your application, right? Like, you don't want to step on each other's toes. You don't want to make changes in parallel that are conflicting or have any conflicts, right? And there's a tool that's called Terraform Enterprise, and what this does is it allows you to use a version control system like GitHub or Bitbucket or whatever tool you want to use, and so you have a central repository for coordinating those changes. And so you have this state file, and you can check in this state file into your version control system, and you manage this configuration file in a way to avoid all of these conflicts. Okay, but now let's say you're doing really well, and what if you have like more than one team for developing your infrastructure and for managing your infrastructure? This is a great time to use what's called a module. And in a module, it's basically a container for 2 or 3 different types of resources. So let's say you have different DevOps teams, different developers. You have a front-end dev team, you have a back-end dev team, and people need to update infrastructure, people need to remove infrastructure, people need to add resources and delete resources. So if somebody wants to create a resource, they don't necessarily need to know all of the specific pieces that go into building that resource. Like, let's say I want to create a new database or a new table for my database. And the DevOps person says, okay, here's a module, and this is how you do it. And it's kind of just a black box of infrastructure where you can combine different resources and different configurations, because as an engineer, maybe I don't necessarily need to know all of the details and all the configurations of that table. I can just create it, using this module, using this black box of information that the DevOps that the DevOps person gave me. And so what happens when you use modules is you encapsulate complexity of different resources, and so it's accessible to a number of different people. And so again, I might not need to know all the details of a specific part of the infrastructure, so it might be better to use a module versus, create every step of that infrastructure. Most cloud providers have what's called a registry. I know AWS has their serverless patterns collection. That's something that I worked for when I was at AWS. There's also Google has to have their own, registry of configuration files that are pre-built. Terraform has what's called a Terraform registry. These are all examples of pre-built configuration files with blocks of code that you can use in your configuration file. So let's say, you can go online and say, I want to build a Lambda function. Give me the code for the Lambda function. And so you can, copy and paste that as a starting point, so you don't have to start from scratch and say, like, how do I build this from zero? You have this, pre-built block of code with certain configurations, and you can edit that configuration as you go, but you don't have to start from zero, which is great. So you can also import your existing infrastructure into your configuration files, and there's ways to do this with every provider. Every provider does this. All you have to do is find the corresponding resources online, and then you migrate those into your configuration files. And the process is kind of the same. You identify the infrastructure that has to be imported, and then you import that into your Terraform state file, which is your configuration file. Then you write the configuration file, make sure it matches what's currently in production. And this is where I would say it's beneficial to use a test environment. If you've seen me speak before, you know how much I hate using test environments or QA environments. I'm a very strong advocate for testing in production, but this is the one place where I would say if you're migrating your entire infrastructure, it could be beneficial to use a test environment. We talked about this before, but one of the benefits of Terraform is that you do have the ability to do multi-cloud. Does anybody here use more than one cloud provider? Okay, raise your hand if you use one cloud provider. Okay. You use two? Okay, great. Great, okay. I think in the future there's a lot of data that shows companies are moving to multi-cloud. So if that's something that you're interested in, Terraform has a really great multi-cloud approach. Okay, let's recap the advantages of using infrastructure as code. So it enables everybody, regardless of their experience, to be able to use and self-service their infrastructure. So, if I don't have a back-end experience and I still need to work in back-end, using these configuration files and being able to self-service my infrastructure is really, it makes everybody's job easier, right? I don't have to go figure out how to do things in the console and take online classes to figure out how to build things. I can just go into the configuration file, copy and paste whatever resources I need, fix whatever configurations, and there you go. It's done. It's very fast. You also get this natural progression from day one to day two to day n, where your processes don't change throughout time. So as you're editing these configuration files, you're evolving your infrastructure over time. You have this natural progression that's evolving your application. Your complexity is increasing or decreasing. And then you also have this natural progression from single person to small team to entire organization, and you have the flexibility to use things like modules where you don't necessarily need every single person on the team to know every detail about what's happening in the back end. And you have a single unified delivery of all of your tools all in one place, so you get this really holistic overview of what's going on in your application. And you can also import your existing infrastructure, and you can do things like multi-cloud. Okay, so you do have a bunch of choices when it comes to infrastructure as code tools. And like I said in the beginning, I don't care which tool you use. There's Terraform, AWS, Google, Azure. There's 100 other cloud providers, but these are some of the biggest ones. So I don't care which tool you use. I just would like you to try infrastructure as code. So we talked about Terraform a little bit. The key differentiator between Terraform and the other tools is that Terraform lets you deploy resources from more than one cloud provider. So if you're using, a database in AWS and a server from GCP, you can manage that all in one place with Terraform. And they also have a registry with pre-made resources that you can go into online, copy and paste them into your configuration files. AWS has two different infrastructure as code tools. One is CloudFormation and one is SAM. So CloudFormation is just the main infrastructure as code tool. This is where you can define your templates, and SAM it's called the serverless application model. It's built on top of CloudFormation, and it's for serverless specific resources. So things like DynamoDB and Lambda and SQS, things like that. Those are all built from SAM. So you can use CloudFormation, you can use SAM. If you do decide to use AWS, there's a great resource that I worked on. It's called the Serverless Application Patterns Collection. And this is an open source repo online of different SAM templates that are pre-built for you, pre-made. It's a really great way to start building with serverless if you've never used serverless before. Yeah, that's it for AWS, I think. Next is Google. So Google also has templates that you can use online. Google also has a Terraform provider that you can use with Terraform. What else? Terraform is written in HashiCorp configuration language. It's like their own version it's like their version of a YAML file, but it's not YAML. AWS uses either YAML or JSON. And so, like I said, it doesn't matter what tool you use to provision your infrastructure. The important thing is to capture this process in a way that can be repeated and scaled and automated. Okay, so we're going to go through a demo, and I didn't record this live. It's just screenshots. But I'll give you a QR code at the end that goes through all the steps, so you don't have to write any of this down. So today we're going to be using the Linode Terraform provider. So Terraform has a lot of different providers, and we're going to be using the Linode one mostly because I work for Linode. Okay, so the first step is to generate your SSH keys. It's funny because when I worked at AWS, I was on the serverless team, and so I didn't have to manage servers at all. And then I came to Linode, and it's all servers, and now I have to learn how to use servers. So SSH is how you connect to your servers. It's how you authenticate and how you connect to your servers. And this is what it looks like. For SSH key authentication, you have a private key and a public key. And you need to create an SSH key, and you're going to add this to your configuration file. And the way you do this is with a keygen command that we're gonna talk about in a second. Okay. In order to generate your SSH keys, again, this is how you securely access your resources that are on a server. This is how you can securely transfer files. This is how you can, run different commands. This is like when you run, Terraform commands, for example, Terraform refresh, plan, and apply. This is all done through SSH. And you do this with the SSH keygen command. And then you get this message saying, okay, we're creating a key pair for you, and then you choose where to save it. You create a passphrase, and then you copy it into the root user's SSH directory, and you do this with the SSH copy ID command. And then you have to add your IP address. So your IP address is going to be different than the one that's on here. You can find it in your Cloud Console. And so now you have this secure connection. In this case, you're connecting Terraform to Linode, and this is how you create that connection. Next, you need to create a Linode API token, and you do this from the UI. And then you create also this personal access token. This is how you create your API token. Once you create it, you can select your access levels, and then you install Terraform. So this is the fun part, right? You create this new project directory, navigate to it, and then you verify that Terraform can run. And next is where it gets interesting. This is where you create your configuration file. So the easiest way to do this, I think, is to just type nano and then the name of your file. It has to end in .tf if you're using Terraform. You can also go into, if you're using SAM, for example, it'll be a template.yaml file. But you can go into like VS Code or your whatever tool you want and create it from there, but I think it's easier just to do this from the terminal. And inside of your configuration file, you need to list out your API token that you just created, your SSH key that you just created, and the root password for your account. And so this is kind of what it looks like. We're creating this resource. The name of it is Terraform Web Example. It has the Linode provider. You can add whatever you want here. This is like what's great about having infrastructure as code is that you have the flexibility to add, remove, update resources. It's all in one place. Everyone can see what's going on. So next you run Terraform init. It just initializes Terraform. Then you run Terraform plan, and this again creates the execution plan. It's going to look at the configuration file and say, okay, this is what you want to create. You want to create this one instance. You want to perform the following actions here. It says you want to create this Linode instance. It's called Terraform Web Example, and at the bottom, it's going to add this one resource. So now it has a plan of what it's going to do. And then when you run Terraform apply, it's going to actually perform those actions for you. So it's going to go ahead and create or update or destroy whatever resource is. And then when you go into your UI, whether it's Linode or Google or whatever provider you're using, you can go ahead and see that it was created. In my experience, the Terraform providers have a faster deploy time than AWS or Google. I think the deploy times for those take between 4 to 6 minutes, depending on the configuration file. The Terraform Google provider and the Linode providers are very, very fast, much faster. If this is something that you want to try, we do have a tutorial online for Linode and Terraform. There's also other providers online. There's Linode and sorry, I'll go back. Linode and every other provider. There's also, outside of Linode, AWS tutorials where they go through the serverless patterns collection. There's, Google tutorials. There's all sorts of ways that you can start building with infrastructure as code. So there's a ton of learning resources that you can use to start building with infrastructure as code. Linode has a YouTube channel. There's also a DevOps community. Terraform is an open source project, and you can contribute if you'd like to add a new resource or update something. But I hope that I convinced you all to use infrastructure as code today. And thank you. I will take questions now. Oh, I also have my Twitter here in case you guys have questions. If you want to send me a message or whatever, send me memes.
Hi, Talia, thanks for your presentation. I would like to ask you a little bit more about why companies are moving to a multi-cloud
Sure.
approach. So
Yeah.
if you could elaborate more on that, thank you.
Yeah. So one of the biggest reasons that companies are adopting multi-cloud is they don't want to have all their eggs in one basket. So like, let's say there's an outage and, AWS goes down. What do? Like your entire application is just down. So that it's one way to have fault tolerance. So just in case servers go down in one place, you still have a backup in another place. It's also a way to distribute your load. If you have servers in different places and different cloud providers, you can distribute that to different companies. There's also like something I read online that you don't want your tool, what you're doing, to compete with your cloud provider. So I think this is an example of like Amazon, for example. Amazon's an e-commerce company as well as a cloud provider. And so like e-commerce companies are moving away from using Amazon because it's a competitor to them. So using multi-cloud is like one of the benefits. One of the benefits is the distributed cloud. You have resources in different places, and it's also you're moving away from using competitors to your own. If, for example, e-commerce or streaming like Amazon Video, you have a different place to put your resources. I think there was another question. Yeah, up there or here.
Sample you show.
Yeah.
The rest that you put the password and there is no problem with security because this is plain text, no?
Yeah, so you can encrypt it for sure. Great, thank you for calling that out. You can encrypt text in your configuration files. So you don't want to put your password in plain text in a configuration file. Definitely encrypt it, and you can do that through every cloud provider. No matter what you use, they'll always have a way to do that. Thank you. I think we have one down here and one up there.
Hi, just a quick question. Oh, apologies, my voice is a bit
So
short right now.
It's okay.
Yeah, when you go with infrastructure as code, you usually face down the road, especially in large teams, the issue of centralizing versus decentralizing. What is your experience there? Because I've seen both worlds suffer the pain of both, and I'm not really sure what I would recommend right now, because you have the agility that you can give to teams when you distribute it, but then again, you have your specialist, even if you distribute knowledge or whatever, you have your specialist that when something goes wrong, need to be able to quickly assess the state of everything. And distributed states usually are much more difficult to manage and assess than centralized ones.
Yeah, I think one of the best ways to manage that is to really have really good permissions on who's allowed to change what part of your application. And then you can also, like in GitHub, for example, make certain people have to review or certain people have to sign off on changes. But I would definitely suggest using a tool like GitHub or Bitbucket or like having a central repository, because you have all of those changes in one place. It's always going to be, there's no like perfect solution, but having people who are like you said, those specialists, the SMEs who are subject matter experts, having those as like sign-offs on or approvers, sorry, on the GitHub request, that's a good way to do it. You also just have to have like as much transparency in your teams as possible, talking to people ahead of time. There's, using infrastructure as code is a great way to see everything in one place. You just don't want to give everybody access to it who doesn't need access. So like I said, modules is also a really great tool to use. So if you don't want specifically, front-end engineers might not necessarily need to know all the stuff that's going on in the back end. They could use modules. And then again, like permissions, like you don't want people to be able to access things that they don't need access to. So it's called the principle of least privilege. So that's something I would implement too.